so today we are doing an intro to parent functions. We are going to be using some of the transformations we talked about in 1.1 with the parent functions. But a parent function is just the most basic function in a family. Okay? It's not a put down in the math world, right? So it's just the most basic function in the family. All right, so when we go over these, some of them you are already going to know. So we're going to start with the families. Let's meet the families. Okay, so the first one is constant. Remember, constant is just a numerical value. So depending on the equation, that will change. But a constant that you might see is like y equals 5. And 5 would be the constant. Okay, the next function is the linear function, which you are probably the most familiar with. And then the second most familiar is the quadratic. We're also going to talk about the cubic function and then the square root function. Okay, the rule is just the equation. So we're going to do the equation for each family. So for the constant, we have f of x equals c. Remember that f of x is just function notation. F of x operates the same way as what variable? Y. Great. Okay, so f of x is just function notation. Okay, so for a constant, it's f of x equals c, where c is going to be the constant value. Linear is f of x equals x. Quadratic is f of x equals x squared. Cubic, f of x equals x cubed. And then the square root is f of x equals the square root of x. Okay, notice the exponents on the x values for linear, quadratic, and cubic, because that's what you're going to use to identify when you're given a function. All right, the next thing we're going to do are the graphs. So some of these you might remember. For a constant, that's going to depend on what the constant is. Does anybody remember what it would look like? Like if you had y equals 5, what would the graph look like? Remember? Yeah, horizontal line. Yep. It's always, yeah. We always get confused between this one and this one. If it's y equals, it has to go through the y-axis. So I'm just going to have you guys draw a rough sketch of that. I put the C there because it's just going to depend on what that value is. You can put that horizontal line anywhere. Just label the y-intercept as the C value. And then some of you might feel confident enough to graph the linear function. Or if you guys want, you can put your x, y for all of them. We're going to do the basic axis, the x and the y axis. Whenever you feel brave, you want to try the linear one? Okay, so with a linear function, do you guys remember the form that you would have talked about linear functions most of the time? Y equals there we go, mx plus b, okay? So the m is the slope. So what's the slope of our parent linear function? You guys got this. Come on, what's the slope? It's the number in front of the x. What's the coefficient of x? 1. So the slope is 1. What's the y-intercept for this one? 0, because it's the plus b, so that would be 0. All right, so if I start at 0, 0, I just go up 1, over 1. So you can kind of see my little dots there. I just went up 1, over 1, up 1, over 1, up 1, over 1. So it's a straight line that goes through 0, 0. You guys remember the name of the quadratic shape? How about what it looks like? the quadratic function look like? Yeah. It is. It's a parabola. And it is shaped like what letter of the alphabet? U. A U. Okay, so for x squared, think about too, when you're creating these parent functions, you can plug in values and find out what the output is. So if I plug in 0 for x, what's 0 squared? 0. 1. 1 squared is? 2 squared is? And then what about the negatives? So if I plugged in negative 1, what's negative 1 squared? 1. Negative 2 squared is? 4. So that's what creates the U shape, right? When you plug in the negatives, you're still getting out the positives. Can any of you describe what the cubic function looks like? Some of you just think of it. Can you guys see it in your head? It's okay if you can't. But if you can, you guys think of it like a squiggle, kind of? Like a stretched out letter? I'm going to tell you a new way to think of a cubic function, okay? A cubic function is the right half of an upward parabola and the left half of a downward parabola put together. Okay, and then sometimes they're skinnier, sometimes they're wider. Just depends on what kind of stretch or compression that we have. Okay, but the cubic is parabola going up, parabola going down. And for the square root, let's think of the same type of things, right? If you have an x and a y, okay. So if in Algebra 1, when you guys were making tables, a lot of times did you plug in -2, -1, 0, 1, and 2? Yes. Okay. Some of you yes, some of you like, don't make me remember that part. Those are great things to plug in. So if I plug in -2, you guys can try this on your graphing calculator if you don't remember. What is the square root of -2? What do you get? What does it say? Try it. Yeah, it says error, right? Why? What does yours say specifically?
Error, non-real answers.
Oh, okay, yeah. I wasn't sure if it would say domain error, but yeah, non-real answers. Does some of yours say domain error? Does yours say non-real answer too? Oh, okay. So we can't have a real answer when we plug in a negative value. We're going to talk about what happens. They are called imaginary numbers, and we'll talk about those later this year. So when you plug in a negative, you can't take the square root of a negative. What about 0? What's the square root of 0? 0, right? Because 0 times 0 is 0, so yeah, that works. What's the square root of 1? 1. What's the square root of 2? Or sorry, square root of 4. That would be a decimal. 2. So if at 4, I'm at 2, right? This is going to look like this, which also is very similar to a parabola. It's just rotated. Okay, so this is your square root function. Okay, and we'll keep talking about those connections. Some of the stuff that you guys have already told me today is going to pop up in another section. So the next thing we're going to talk about is the domain. How are we feeling about domain and range? I always felt like people were not really confident on that. Okay, so the domain, do you guys remember what the domain has to deal with? Not sure? Okay, so the domain is going to be numbers that you can plug into the function and you can get a real answer out. So some of you just tried to take the square root and it said non-real answer, right? That means there are going to be some guidelines for the square root. But for a lot of functions, you can plug anything in and you can get something out. Do you guys remember what that's called when there are no restrictions? It's probably the most common domain you guys have heard of. It starts with all. Oh, you guys, I thought we were finishing each other's sentences, guys. Remember all real numbers? Does that ring a bell? All real numbers? So we're going to talk about that today. So the domain is the x values or input. Sorry, that's really small. So the domain, I just put a little thing here, a little note. So we remember that's the x values and the input. So because there are so many things that you can plug into a function, it's actually easier to think of the exclusions because there's so many things you can plug in. And if there are no exclusions, the domain is all real numbers. So for something like y equals c, okay, for something like y equals c, c can be any value. I'm just going to stick with 5, okay? It doesn't matter what I plug in for x because there's no input. I'm always going to get out 5. So technically, I can plug anything in and get out a constant. And that's what makes the straight line. So the domain is going to be all real numbers. Do you guys remember the symbol for all real numbers? It's a capital R with a line through it. So it looks like that. Your book makes it pretty fancy too. So you'll see me use one of those two things, either all real numbers or that capital R with the line through it. Okay, so that means a set of all real numbers. Did you guys know there were imaginary numbers before today? Some of you, yeah, some of you no. All right, so linear, you have f of x equals x. So we want to think about what can I plug in there that's going to produce produce some type of answer. So I always think in terms of negatives, 0, and positive. So if I plug in a negative number, yeah, that's fine. I would still get an answer. If I plugged in 0, I'd still get an answer. If I plugged in something positive, I would still get an answer. Can you guys think of any other times where you try to do a calculation on the calculator and you get some type of error? So we just did one with the square root. Is there any other that you can think of? Yeah, Lizzie? Yes, dividing by 0. So like if my function was 1 over x, I'd have to be careful because I couldn't plug 0 in there. But we don't have that, so all real numbers. For f of x equals x squared, I can plug in negatives, I can plug in 0, I can plug in positive. That's going to be all real numbers. You can also look at the graph because you can see that the arrows mean this is going to span in the positive x direction and the negative to infinity. So it's all real numbers. Same thing here. This is going to keep going, so it's going to span that horizontal axis. Same thing with x cubed. Okay, so all of those are all real numbers. Square root, though, that's a different story. Because we talked about with the square root, you can't take the square root of a negative number. You can take the square root of 0, though. Do you guys remember how we can write that using symbols? We did it the other day using h and k. Do you guys remember what symbols we used? We say like h is what? Yeah, we'd say, oh, if it's moving to the left, h was less than 0, right? If it was moving to the right, h would be greater than 0. So for this one, to show that it's positive, because the domain deals with the x values, we're going to say that x is what?
0 or more than 0?
Yes, how can we say that with a symbol? So before we weren't including 0. Do you guys know? Yeah, what is that symbol? No? Yeah? Yeah, good. So x is greater than or equal to 0. Good. So what that means is I can plug in anything for x as long as it's 0 or above. Okay, the negatives would not be allowed. All right, now the range is going to have to correspond to our y values and our output. So sorry, again, I know that's kind of hard to see, but I want us to look at the graphs for this. So for the range, will you guys just make a little note that it's y values and the output? Okay, and the constant one, that one is special. So remember with our y equals 5 example, I said it doesn't matter what you put in, you're always going to get out 5. So no matter what you plug in, you're always going to get out c. So your range for this one, for a constant, is just going to be that number of y equals c. All right, and then for the range, you can also look at your y-axis. So in terms of the vertical axis, this is going to keep stretching upward. This is going to keep stretching downward. So that's going to be all real numbers. Okay, quadratic is not going to be all real numbers. So I want you to take a look at the graph. Look at all the y values that are represented. Yeah,
They have to be positive numbers.
exactly. They have to be positive numbers. And then also think, are you including 0 or are you excluding 0? Including 0. So do you guys think you could write that for that one? Okay, so instead of x this time, we're just going to use y. So y is greater than or equal to 0. All of them are positive. Okay, what about for cubic? For cubic, I see at 0 and positive, it's stretching up here. 0 and negative, it's stretching down, which means it is an all real number situation. Okay, and then the last one, the square root of x. Again, look and see where your points are. So I have 0 and then above, and this is going to continually keep going up. So this is also y is greater than or equal to 0. Okay, and then the last one is where it intersects the x-axis, which is really just what? That's your y-intercept. Okay, now the y-intercept for the first one is going to depend where the constant is. And so that's going to be 0c. For the rest of them, you should be able to pick out the y-intercept from the graph. So you guys write it down on the graph for me. All right, what did you notice about all the intercepts? What are all the rest of the intercepts? 0, 0. Okay, and then just make sure you guys do the proper notation for that with your parentheses, your point parentheses. I know probably last year was a little lax with some things, but in honors and moving forward, we're just going to tighten up some of that notation. Okay, now for our first example, there are multiple directions. So you'll see a lot of compound directions. That's why we're going to use the highlighter. I want you to highlight. There's multiple things that example 1 is asking you to do. If you guys can pick out some of those math action words, okay, and highlight the different things they're asking you to do there, that would be great. And then I'm going to call on a few of you to tell me what those things are in about 30 seconds. Alright, so Dane, tell me one of the things we're going to be doing in this example.
Identifying the parent function.
Good. We're going to be identifying the parent function. So we're going to have to say whether or not it's constant, linear, quadratic, cubic, or the square root. Okay, Brianna, what's something else that we're going to have to do? Yes, we're going to graph G on our graphing calculator, and to make that visible on our homework and in our notes, what I'm going to have you do is just draw a rough sketch, and I'll do that with you so you can see what I expect, okay? So, again, like I said, I like to highlight. So identify the parent function, okay? That's the first thing we have to do. Okay, the second thing is graph G. Okay, and we can use the graphing calculator for that. If you, if by some, I know you guys either have a graphing calculator or you checked one out. If you're ever in a pinch though, feel free to use Desmos, which, did some of you use that for Algebra 1 because you're online? Yeah. I'm completely fine with you using that at home, okay? And then, Jack, what's the last thing that we're going to have to do for this?
Just describe the transformation of the parent function.
Good, good. Describe what transformation of the parent function it represents. So, 1, 2, and 3. All right. So, step 1 for part A. G of x equals x minus 3. Can you guys tell me what the parent function is?
Linear.
Yes. How did you know that, Ava?
Because the x is just an exponent of the kind of like square or square root of.
Perfect. The exponent on the x is a 1. There's no 2, no 3, no square root. Perfect. So yes, it's going to be linear. Okay. The second thing is we are going to graph, and then we are going to draw a sketch. So on your homework, you're going to be drawing a sketch if it says to graph that. And I really do mean a rough sketch. Like we're not going to be plotting points. We're just going to get the general shape of the graph. And how many of you have graphed on the graphing calculator before? Yes, just a couple. So I'm teaching you something new today. I'm pumped up. We're going to learn how to use these beautiful things. So when you are graphing on the graphing calculator, I'm just going to put a little thing here that says graphing calc. Okay, what you're going to do is you're going to hit the y equals button. Okay, which is located right here. Oops. Hopefully yours is clear. Okay, and then we are going to type in the x minus 3. So the x is right here. So we're going to do x minus 3. And again, the way that I did that is I used this variable button for my x. You can see it says x, t, theta, n. The other variables are for different modes of your calculator. For this year, we are going to be sticking with the x, but if you go to pre-calc next year, they do all the other ones. You can also use the alphabet x, but I feel like this one is quicker. Okay? So you're going to enter that in. On our steps, I'm just going to put in type equation. EQN is my equation. And then you are going to hit the graph button, which is this guy here. Now, most of your calculators, this is your first time using them, they will give you a standard 10 by 10 window, which means it's 10 units to the right, 10 units up, 10 units to the left, 10 units down. But some of you might be like, oh no, mine does not look like that. That's okay. If you have a different window setting, I'm going to show you a quick way to get the standard window. You can press zoom. So I'm going to put 10 by 10 window. You go to zoom. And then you can arrow down to 6, or you can just press in 6. If you just press in 6, it'll do it for you. So if you did not have that standard window, if you press the 6, you should have it now. So that's zoom, and then 6 is called Z standard, and it does that for you. Okay, as we get more into it, I'll show you how to use the window button, where you can make it go -10 to 10, scale by ones, -10 to 10, scale by ones. And then just go back to graph if you need to see that graph. Okay, so once you've done that, I want you to just do the rough sketch. Okay, and then if you feel like you can do step 3, go ahead and do that. If you're unsure about that, will you guys go to B and do steps 1 and 2 for B? And then I'm going to come around, so if you guys did not get that on your graphing calculator, I will help you. Sometimes the stat plots get turned on by accident. Okay, so let's finish number 3, and then I need to remind you something about number 2. So for number 3, were you guys able to tell me what the transformation was? Good, yes. Translation, 3 units down. And then for the linear function, it's really going to be up or down. If there is a translation. So this is the translation, 3 units down. Now, the reason why the second one, we have to do a reminder when we are putting things in is because you have this negative here. The parent family, Gwen, what did you put for that one? What parent family is this one? Good. And then how did you know that? Yes. Good. Okay, so we know it's quadratic because the exponent is 2. So anytime you see the x squared, it's going to be quadratic. Now, when you are putting this in your calculator, for the negative, you have to use the negative key, which looks like this. And so if you use the subtraction key and you tried to graph it, it would have told you that there was a syntax error. And the syntax just means that we use the wrong symbol. Okay, so we're going to go back to the y equals. And then here's your negative key right here. So we're going to do negative. And then did you guys figure out how to do the x squared? There's two ways you can do it. So did some of you use this, the exponent key, the to the power here? Yep, so you can do to the power of 2, or, did some of you use a different way? Yeah. Yeah, you can also use the x squared right here, and when you do that, it makes it squared. So you do have to put the x in and then do the x squared, just so you know. And then you have the plus 5. Okay, and then we're going to graph it. So, again, we're just going to draw a rough sketch. And there were 2 transformations in here. Did you guys get both of them?
Reflection across the x-axis.
Yeah, so that was the one I was wondering if you guys would get. So the first one, you have the plus 5. which would be a translation 5 units up. And then this negative also means that there's a reflection. And when you have a reflection, make sure that you tell me what it's over. So in this case, it's over the x-axis, because your original function, right, your original parent function was like this. So if you think about that, the reflection over x means that you would flip it downward. Okay, and then from there you do your up. Okay? All right, good work. All right, so on the next example, it's going to ask you to graph the data from the set of ordered pairs. Before you start plotting, I want you to look at the values of the ordered pairs, because we are going to have to make sure that we scale it. Okay, so we have to graph the data from that given set. We're going to describe the parent function and the transformation that best approximates the data set. All right, so based on the graph that I'm given, I have to get all the way up to 12. You guys can decide if you want. You can go by threes. Okay, you could go by twos and be a little bit off it. It just depends on what you want to do. Okay, and then so that's why we just need a label. So I would go 3. 3 plus 3 is 6, 9, 12. And then remember, your graph scales do not have to be the same. So I could have this by ones. So this would be 1, 2, 3, 4, 5. -2. All right, so let's go ahead and graph that. So I have -2, 12. -1, 3. 0, 0. 1, 3. And 2, 12. All right, so right away this looks like a what? Yeah, quadratic. And so make sure that you guys put your curve on that. So the parent function is quadratic. Okay, now for the transformation, what you're going to want to do is compare the new data points that are given to the original parent function. Okay, so you might not be able to recognize the type of transformation from the graph alone. If it's just a translation, you're going to be able to recognize that, right? If it's 3 units up or 3 units to the right. But if we have something where there's a horizontal or a vertical compression or stretch, what we might want to do is look at the x and y coordinates from the parent function and then compare those with the data set. So that's what we're going to do. So we're going to look at the parent function for the quadratic, which is f of x equals x squared. And then we kind of already did this part verbally. I told you, oh, what happens if you plug in -2? -2 squared would be 4. And it's a good general rule to use -2, -1, 0, 1, 2. If you do that here, you can see the x's would be the same. You can compare the y's. So -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. This would be the table for the parent function. Okay, and you can always use this for your parent function, for your quadratic. All right, now let's look at the new data set. So we're going to compare the y's. Okay, so all of our x's are the same, but our y's, for -2, we have 12. For -1, we have 3. For 0, we have 0. If you plug in 1, you get 3. I'm going to put the data set y. For 2, you get 12. So what you want to ask yourself is, okay, what's happening with these y's? I went from 4 to 12, 1 to 3. It stayed the same here. 1 to 3, 4 to 12. What's happening?
It's multiplied by 3.
The y's are being multiplied by 3, right? 4 times 3, 1 times 3. Okay, so x is the same. Compare the y values. They're being multiplied by 3. Okay, so if the y is changing, our rule went from xy to x3y. So if the y coordinate is changing, it's going to affect the vertical. Compare the y values. Y changes. Means that it's vertical. Is this going to be a vertical stretch or compression?
Stretch.
Yeah. How do you know it's a stretch? Oh, yeah. You can think of the graph. What about the value? What's going to be the factor?
The y's are going up more, the y's going up more.
But it's going to be going up by a factor of what for each one?
Oh,
3. And then remember, it's a stretch if the value is greater than 1 or less than -1. So it's a vertical stretch by a factor of 3. If instead of 3 it was 1/3, then it would be a compression. All right, and the last one, example 3, is going to be a real-world application. So you are graphing the relationship from year to sales in millions of dollars, and then identify the parent function, and then we're going to use the graph to estimate when the cumulative sales, I should say, reached 10 million. So we'll do 1, 2, 3 steps there. 1, 2, 3. All right, so to graph the relationship, we have the year and then we have the sales in millions. So our y-axis is going to be the sales in millions of dollars. And our x-axis is going to be the year. So I have to go from like 0 to 12, and I have enough to go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then for the years, I'm going to spread them out because I only have to go to 5, so I'm going to go by half. So 1, 2, 3. You wouldn't have to do that. I just if I have the room, I like to spread it out. Okay, so let's go ahead and plot our points. So at 1, I'm at 0.6. So this is 1. So 0.6 is about here. At 2, I'm at 1.8. I'm close to 2. 3 is at 4.2. 4 is at 7.8. And 5 is at 12.6. All right, so we graphed. What type of parent function do you guys think would fit this best? Not linear, right? What about quadratic? Does kind of look like it's curving up here? Yes. Okay, so we're going to connect those with a curve. Okay, so identify the parent function. It would be quadratic. And then it says use the graph to estimate when cumulative sales reach 10 million. What I would do is use my highlighter. And then all you're going to do is look for that intersection, and you're going to estimate based on your graph. So for me, mine's right here. This is a little bit more than 4 years, right? But not quite 4.5. So I might say approximately 4.2 years. If you have anything between like 4 and 4.5, that will be great. Okay, so 4.2 years and quadratic. All right, and then I do have graph paper for you on the back table if you want that as you are going out, and then I will check this tomorrow. Again, remember with your homework, the textbook homework, the 1 through 16, if you do all of 1 through 16, I'm going to give you points for that. If you can only make it through half tonight, that's okay. I won't put anything in the grade book for this section. Okay? Oh, thank you. Yeah, mine is the, oh yeah, mine is, yes. So, yes, I would say 4.7 or 4.8. Yes. Thank you guys. So I went by the halves. And just feel free to grab a sheet of graph paper on your way out.